My name is Landon Stevens. I am the group leader on the jet engine experiment for our group. In our next week's lab, we will be using the jet engine experiment. The jet engine that we will be using is a scaled-down version of a real jet engine that they use on airplanes to create thrust. And since LSU has so many budget cuts and they don't have the funds to acquire a real-life engine, we're going to use this scaled-down, cut-down version that turbine technology provided LSU. As you can see here, it's much smaller than regular jet engines. It has the same compressor blades, turbine blades, nozzles, and fuel storage. But this one is actually powered by LSU's power supply instead of a generator that most jet engine aircraft use to power their turbines. So as you can see here, it has its nozzle which draws in the air into the compressor blades where it's compressed to high pressures. It's put into the combustor mixed with the fuel mixture, combusted, sent through the turbines, and out the converging nozzle to converge all that thrust coming out to create the thrust. And it has several different temperature reading sensors and several different pitot tubes throughout its system to measure the airflow through it to get the varying temperatures and pressure throughout the system. Thermodynamics behind a jet engine are very basic. As you can see here, we're going to use the ideal brake cycle. 0 to 2, that inlet is where that nozzle takes in all that air into it. The compressor blades compress it from a temperature here to 3. And from 3 to 4, that's where the fuel mixture is mixed into the combustor and is ignited. The turbine blades push this mixture of air and fuel out into the nozzle where it creates thrust. In a real braking cycle, these lines right here will actually be canted, will be canted inward and outward to show the change in entropy, but for our experiment, we're going to assume it's an ideal process. During this experiment, we're going to run the experiment through several different ranges of RPMs that's measured by the tachometer in the turbine's generator, inside the jet engine's turbine generator. These will range from 40,000 to about 80,000 RPMs. The temperatures will be read from the sensors from 1 to 5 in Fahrenheit. Pressure will be read from sensors 1 to 5 in PSI. The voltage is the voltage that the fuel meter reads in millivolts, and the thrust force is measured in pounds. This is how much thrust that the jet engine is actually producing. Based on this, these following equations that I'll show you later will be used to calculate these calculated values right here, which will be used by the group reporter in graphs, and they will be plotted against the RPM. This includes the mass flow air rate, the thrust that's calculated, and the thrust that's measured by the jet engine thrust measuring device, fractions of fuel burn throughout the jet engine, the turbine and compressor work compared to each other to see how efficient it is, and the compressor isentropic efficiency. These three equations here will be used to find the mass flow air rate. They'll take the pitot tube and the static pressure to find the velocity, back out the velocity, plug in the velocity, back out the mass flow air rate, and also they'll use that to find the heat added into the whole engine, and this will be used by the group reporter to compare to other different heats added by the different parts of the jet engine. The thrust calculated will be used with the exit velocity and the mass flow rate of the air, and they'll compare this to the measured thrust. Fraction of fuel burn in the combustor, you get the heat added by the combustor divided by the heat added by the fuel to get the fuel burn in the combustor. Same with the fuel burn in the nozzle, heat of the nozzle divided by heat of the fuel to get our fuel burn in the nozzle. And then the combustor and turbine work will be used with these three equations. You get the work of the compressor using the mass flow air rate and the temperatures here. Then you'll find the heat added into the turbine using the heat of the fuel and the fuel burn through the combustor and the nozzle. And then you'll find the work of the turbine, adding in the heat added by the turbine itself. And you compare these to see how efficient the system is. The reporter will use all this information to show you how the jet engine, how efficient it is, and how the pressure readings throughout and the temperatures readings relate to how much thrust is actually produced by the jet engine. Now what I did is I went in and I took some of the data given to us by Turbine Technologies that they measured through when they were building these engines, and this includes the engine RPMs, the fuel flow rate in gallons per minute, and the fuel meter voltage, which is measured in millivolts. And I actually produced these fuel curves right here to show you how efficient this is, and also to show you what you're going to be seeing from the group reporter. As you can see, with increased fuel flow, you get an increase in engine RPMs and fuel meter voltage. This will be true when you see the increase in the pressure will increase the thrust, and also the reporter will show you how the increase in the temperatures will increase the thrust, and also your fuel flow rate will actually get much more with this increased thrust because you need more fuel for more thrust. That being said, are there any questions?
Yeah, so like you said, like the thrust increases as the fuel flow increases. So can you say, like, as the speed of the jet increases, what you measure the RPM? Like, how would the thrust behave with them?
Well, the thrust is actually correlates to the velocity, because what is happening is the faster the air is coming in, the more thrust you can actually produce, which is also, you have to turn the turbine even faster to not only draw in more air going fast, but to also compress it as fast as it's going. So what I'm saying is the velocity of the air going in and out correlates with the RPMs of the generator and the thrust produced by the jet engine.
Okay, so as the RPMs increase, the
thrust increases.
You guys have any other questions?